Hello everyone, this is V. Manikyala Rao, working as Assistant Professor in the Department of CSC and AML, BVRAT, Narsapur. So now we will discuss about in this linear and non-linear models in the regressions. And coming to the first one, linear models. Actually, linear models means it is used to show the relationship between independent variable and dependent variable. So actually, independent variable and dependent variable means, so whenever, for example, if I given y is equal to mx plus c, this is one of the equation for the linear model. So m is our slope, c means constant, x means independent variable. Why we are calling x is an independent variable means whenever we change the value of x, so they need to change the value of y. So y is a dependent variable, x is an independent variable for this one. So they need to show the relationship between the continuous variable and predicted variable. Continuous variable means whenever we need to change the value of x, the particular equation value will be changed and the y dependent variable value will be changed. So here y is our dependent variable, x is our independent variable. Whenever we are changing the value of x, the y value will be changed. So that's why x is called as continuous variable, y is called as predicted variable. So here this is predicted variable and x is continuous variable. So whenever we are changing, for example, x value is 1. So the y value will be m plus c. In case the x value will be 2, means that means 2m plus c. So whenever we are changing the value of x, that means the independent variable value we are changing means the dependent value also will be changed. So this is a form of linear model, y is equal to mx plus c. See, the equation is sales is equal to B naught plus B1 into advertising spend. So here I have taken one example for this one. So here we are taking some 3 months, and for this one we are taking the sales, so and advertising is spend. So whenever we are changing the x values, the sales also increase. So like this, so sales y equal to mx plus c. So this is our slope, this is the constant. Advertising speed means the x values. So whenever we are changing the advertising spend values, the particular sales values will be high. By, for example, if we are given some ad in some TV or some newspapers or any Facebook or any social media networks, so many members they are watching our advertisement, means we are spending some amount for that advertisement. So based on that amount, they need to increase the sales for the particular product. For example, if I am given the advertisement for the laptops or TVs or mobiles, means so the advertising amount will be spent is very high, means the number of sales will be high compared to our advertisement. We are given the feedback for that advertisement. So many sales will be increased based on our advertisement spending for the given products. So that is the general example I taken here. So that is about the linear model. So I taken some example for this one. So based on this one, I solved this one. So now the second step means first we have to calculate the mean. So mean means the sum of all the numbers divided by total number of numbers. So the sum of these sales divided by total value is 3. So 100 plus 20 plus 150 by 3. So that mean value for y is 123.33. So next mean value for x is 600. So now next we need to calculate y dash minus y and x dash minus yx. Why we are calculating means we need to calculate the value of b0 and b1. So for the calculation of b0 and b1, we are calculating y0 minus y and x0 minus xi minus x bar. So 100 is our actual value minus our mean value for y. So these are all the y values subtracted with the mean value of y, and these all the values are subtracted with mean value of x. So like this they need to continue. Now see here, the next step is we need to calculate the values of b0 and b1. So for that calculation, the slope. So first we need to calculate the b0 formula is xi minus x bar into yi minus y bar by sigma sum of xi minus x bar whole power 2. So first we need to calculate xi minus x bar. So xi means that minus 100 into that value. So after substituting the values from the previous table, so that means these are all the values, minus 23.33, minus 3.33 and 26.67. After substituting the values into this one, finally we get the first value, A value is 5000. Now next, the divided by denominator value I given is xm minus x bar whole power 2. So that value we are calculating, finally we get the b value is 20,000. So the b1 we need to calculate is a by b. So that sigma xm minus x bar into y minus y bar divided by sigma xm minus x bar whole power 2. So a by b, so that value is 0.25. So that means 25% of sales will be increased whenever we are increasing the sales for the particular product. Now see interception. So interception means our b naught. So b naught equal to y bar minus b1 into x bar. So the total x bar value 600. So 0.25 and 600. So finally minus 26.67 is our b naught value. So whenever we are substituting into the b naught and finally we get the value, b naught value is 3.33. Now, so our sales is equal to 3.33 plus 0.2 into advertising sales. So whenever, for example, if I give an advertising sales value is 1, so that means 3.53. So I shown this value in this one. So actually linear model means the graph will be, for example, if I given the graph like this. So this is x-axis and this is y-axis. So the graph will be changed like this. Continuously the line will be increased in the form of the linear model. Straight line will be displayed. That is about the linear models that is to be there for this example. So the next one, there are two types of linear models are there. First one is simple linear regression. So simple linear regression means it has only one independent variable, b0 plus b1 plus e. So if the linear model contains only one predicted variable, that means predicted variable means y, x is our independent variable or continuous variable or response variable. So whenever they are changing the response, the continuous variables, that means the predicted variable y value will be increased like this. So simple linear regressions means it has only one independent variable and one dependent variable. That is called it as simple linear regression. So here the x is our independent variable, y is our dependent variable. Whenever we are changing the value of x, the y will be changed. So now here, see, we need to calculate the same b0 v1 value and b0 value. In the previous whatever we are calculated, the same thing. We are taking some example for this one. So xm means the sum of all the instances of x, y bar, x bar means the sum of all the numbers divided by the total count, and y bar is also the sum of all the numbers divided by that count. So now here first we are calculating the x bar and y bar, and now see the values of x bar and y bar, and finally we are calculating x minus x bar and y minus y bar here. So after substituting into the beta 1, and finally we got the equation y is equal to minus 49.9 plus 8.33 into x. So mx plus c, so m value is 8.33 and minus 49.9 is our beta. This is b1 x plus constant value, some values to be there. So b0 is minus 49.9 means it is a lesser value compared to the previous one, and 8.33 means whenever we are increasing the values of the particular equation, the particular slope of the line will be increased continuously based on our equation on the example. So that particular equation will be increased based on our the x independent value, variable value. Based on that we need to increase the value of the particular constants. Now see the linear regression line. So it is a continuous line. So the line will be interact, that means the particular point y is equal to mx plus c. So y equal to minus 49.9 plus 8.33 index. So that will be shown in this linear regression. So it has only one independent variable and one dependent variable. Now coming to the second one, multiple linear regression. So actually multiple linear regressions means it has only one dependent variable more than one independent variables, just like y is equal to b0 x plus b1 x1 plus b2 x2 plus b3 x3, just like the equation like this. So y is equal to beta naught plus b1 x1 plus b2 x2 plus b3 x3 and so on. This is the equation. So here our independent variable is y, b0, beta naught is our constant, beta 1, beta 2, these all are our slope values, x1, x2, x3, these all are our independent variables. So multiple linear regressions means it has only one dependent variable, n number of independent variables are there. So that is called as multiple linear regression. See in this example, so I taken the student ID, this is our serial number. So the multiple x1 regressions, y is our GPA, so that means only one dependent variable, x1, x2, x3, so that means our studying, attendance rate and high score. These three are our variables, just like multiple independent variables, x1, x2, x3. So whenever we are changing the line continuously based on our conditions and the attribute values, so see, I taken the mean for the GPA, so the sum of all the numbers divided by count. So the sum of all the numbers divided by total 4 are there. So 3.4 for GPA A. Next, how was studying x1? So that value 36/4, 9. Similarly, x2, x3 also we need to calculate. So now see this one. So same attendance rate, that value and high school value. So all the attributes we are calculating the mean values. Next, continuously we are calculating the x minus x bar, that means y minus y bar. So these are x minus x bar and y minus y bar. So these all are calculating. After calculating this one, we need to, this is our y minus y bar, so 3.5. So y bar value is what? Y bar value is 3.4. So now we subtracted this value with 3.4. Next, 10 minus the particular standard our studying deviation value is 9. So subtracted with all the values 9, and similarly these values also 0.9 minus 0.8375. So finally we are getting the values like this, and after calculating substitute into this formula to get the values of B0, B1, B2 like this. And after calculating substitute into the equation, so finally we got the beta naught values minus 22.915. So B1 value 0.075, 0.85 and 3.6. So observe this one. So here the x1 bar value is 9, 2.4 and 3.6. Next, similarly after calculating the beta naught value is minus 2.915. So that means the value will be decreased based on that. Observe the previous equation also, y is equal to mx plus c. So that c value is minus value. So that means that value will be is in a negative value. So here also we are getting the value as negative. Now see this one in the continuous. So after substituting into the equation, so y is equal to minus 2.91 for this is our, I already given, beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 4 x4 and so on beta n xn. So now here we are having only three variables. So beta 1 value is 0.075, 2.41 with the coefficients we have to be written. So those values we have to be shown here. So attendance rate along with the GPA. So continuously see, we are having only one line. This is our linear regression line, but all the lines are the multiple independent variables values. That's why we are given the lines like this. This is about multiple linear regression. So finally multiple linear regression means it has only one dependent variable, more than one independent variables, like the attributes, how are studying, high school, solo, those all are we have to be taken, that is to be increased based on our equation. So that is about multiple linear regression. Next one, logistic regression. So actually logistic regression is one of the type of non-linear model, generalized linear model. So it is used to predict the output in the form of binary numbers. So that means that may be 0 or 1, means positive status or negative status. 0 means negative, 1 means positive status. So see this example here. Whenever the particular thing is in a happy state, so that is our positive one, positive status. Sad status, that is negative status. So they need to identify the given predicted variable, that means the output in the form of maybe binary, that means 0 or 1 only. Only two variables values are there. So that is about logistic regression. Only the output predicted variable contains the output in the form of maybe 0 or 1. 0 or 1 means that may be in the positive state or that may be in the negative state. So I taken the particular equation for this logistic regression. So see, P is equal to 1 by 1 plus e power minus z. So P means the probability value. So that means 1 or 0 based on our conditions we have to be taken. So Z means beta plus beta 1 x1. These all are the equation for the multiple linear regression. So the Z means the multiple linear regression values. That means it has only one independent variable and more number of independent variables there. So x1, x2 and so on, these all are independent variables. So whenever we are changing the values of x1, x2 and so on xn, the Z value will be increased continuously. So based on that, we are implementing this logistic regression. Now see, let us take one example here. So we taken some age, blood pressure and heart disease. Now we will identify whenever we are changing the age value and the blood pressure value, the heart disease, they will get the heart disease or not. We need to calculate based on our example. So we are getting the heart disease means they get the value as 1. If we are not getting the heart disease means they get the value as 0. So the output may be in the form of 0 or 1. So now see this example. So let us assume that the estimated coefficients are beta naught value is minus 10, 0.1 and 0.05, 0.1. So beta naught, these all are assumptions. Why we are taking means just we are assuming all are end with 0. So like all are end with 0. So that's why I taken 10 for beta naught. So next in that 1 by 10, 0.1. So in that next one 0.05. In that half 0.1, half 0.05. So based on that assumptions, see, now we are taking after substituting the values into this one to get the Z value is 1.5. So that is P value is 0.8176. The probability value, that means 81%. So with the 40-year-old person, the blood pressure of 150. See, with the 40-year-old person, the blood pressure of 150, they get the heart disease. So they are given the assumption like this. So see, so whenever we are giving the probability of 40 years old age person with the blood pressure of 150, they got 81% chances to get the heart disease. Not accurately 100%. Let us assume that one condition based on our condition values. So they get at the 40 years old person with the high, that means 150 blood pressure, they get the chances of 81% to get the heart disease for the particular person. So that is about one example. Next, we will consider odds ratio, that means based on our independent variables ratio. So odds ratio means e power beta. So finally that value is 10.1.1052. So whenever for every 1 year increase of age, for example, if the age is, so see this example table. So I taken the ages like 25, 5 ages reference I taken here. So up to 45 I taken here, 25 to 45. So next, if I increase the age is 46. So the next, that a high blood pressure is 161 or 165 like this. So we don't know whether we are increasing the age and the blood pressure, they may be getting heart disease or not. We need to identify they get the heart disease or not. They get means they get the value as 1. If they are not getting means the value is 0. So now see, based on this, so for every 1 year increase of age, the heart disease is 10.52%. So for every 1 year, the particular every 1 year, the heart disease percentage will be increased 10% for that person. So finally what we are given, based on our conditions of the age and blood pressure, if the age will be increased, the blood pressure is increased. So based on these two conditions are higher, so they get the heart disease. So at the ages of 25 and 30, we are not getting the heart disease, 0 and 0. So whenever the age will be increased continuously and the blood pressure is also increased, based on that blood pressure increasing, so they get the heart disease values as 1. So the age will be increased based on that age constraint, the blood pressure is also increased based on that certain conditions. So finally the heart disease will get the particular person based on the conditions are to be given for this example. Okay. So that is about the logistic regression. So it contains the output in the form of positive status or negative status. That means binary 0 or 1. Negative means 0, positive means 1. Next, Poisson regression. So actually Poisson regressions means it is the exponential power of the multiple regression. So see this one. So beta naught, beta 1 x1, beta 2 x2 plus 1, beta n xn. So that means the exponential power of the multiple regressions. That means that whenever we are increasing the values of multiple regression value, for example, if I given e cap of 0, so these all the sum of equation value is 0. So e power 0 value is what? 1. So mu value is 1. So that means whenever the value will be lesser compared to the previous values, we are getting the positive numbers. In case if I given that is equal to e power minus 4, so that equivalent, well, for example, some 4.22. So like this, if we are given the negative values, that values will be increased compared to, so 0 will be started, so that will be 1, and if the value will be compared higher or positive, so that value will be increased continuously like this. So that is polynomial equation. So that means it is used to count the particular response variables. So see, it is used to between the count response variables and one or more predicted variables. That means, so whenever we are changing the values of x1, x2 and so on xn, that value will be lesser means we get only smaller values. If that value will be higher means that value will be very high value. Based on that equation, the Poisson regression will be changed. So the Poisson regression like this. The equation, this is x-axis and this is y-axis. So the values will be like this, multiple regression values. Okay, so that is about Poisson regression. This is one of the type of linear model. So this is about the Poisson regression. So Poisson regression, the curve like this. The curve will be like this in either that format, in the down to up format, or like this curved shape format. These are the x values, match time, and the global number for this. So just like the example for Poisson regression. Now next one is gamma regression. So gamma regression, the difference between the gamma regression as well as Poisson regression is, I will show you with the graph. The particular Poisson regression is used to show the value will be starting from, in the Poisson regression itself, the curve will be starting and increasing like this. This is Poisson regression. The condition will be same. In the Poisson regression, the curve will be starting from the origin and that will be increased continuously. That is Poisson regression. In case of gamma regression means they are starting from the origin and that will be continuously increased like this. When we have to change the value 0.04. Okay, so 0.01, 0.0, 0.02, 3. So these values will be increased means the graph will be attached with the highest point of state. So the graph will be represented the gamma distribution. Same as it is as Poisson regression, but the curved shape will be different compared to Poisson regression as well as gamma distribution. This is about the linear models, and coming to linear and nonlinear models. So coming to the survival analysis. So survival analysis means based on the specific action or the event will be occurred. So it is used to analyze the time until a specific event will be occurred for this one. For example, if you are taken for the particular patient getting heart disease, for example, if the particular heart disease, the particular person is getting heart disease. So whenever we are given the particular curing medicines for the heart disease for the particular patient, we need to analyze, for example, the 40 years person, 30 years person, 50 years person, 60 years person. If I have to analyze the previous solutions for that heart disease persons of 40 years, 30 years, 50 years and as well as 60 years person. So based on these all the surveying things, that means based on these all the surveys, we are getting the data. So for which medicine the particular person heart disease will be decreased based on that medicines we have to be given for that aged persons. So that is called it as survival analysis. We are surveying, that means we are analyzing the things based on our conditions they are to be given. So in the survival analysis, coming to the first one, there are two types of models are there. First one is non-parametric models and second one is parametric models. So coming to the first one, non-parametric. So Kaplan-Meier estimator. So it is used to observe the data lifetime. So that means, for example, if you are taking one example for this car as example we are taking. So in this car, the lifetime for that car means based on the usage of the person. For example, if I take an example as car, based on the usage and the performance of the car. So whenever we are using the car, we are using that car with the proper way and with normal conditions, means the car lifetime will be till the end permanently. Up to the last, the car lifetime will be there. So in case if the car usage is very heavy and they are not using in normal way, they are in a heavy condition they are to be used, means the car lifetime will be changed based on our conditions. So that is called as Kaplan-Meier estimator. So based on the conditions, the example will be occurred. See, Nelson-Allen estimator. So it determines the cumulative hazard function. So cumulative hazard function means, for example, if you are purchasing some product, for example, if I have to purchase some bike or if you have to purchase some pen. So if we are using that particular product until the ink will be there in the pen. The ink will be there in the pen. Whenever the ink will be finished, we need to use another file or another pen for this one. In case in the middle of the pen, that means for example if I am purchasing some pen and in middle the pen will not write, they are stopping the particular pen. So the product will be failed. We don't know that one, whether the product will be failed at that particular time. So such type of things comes under this Allen estimator. An interruption will be occurred in the middle of the situation or middle of the product using. That is called it as Nelson-Allen estimator. Coming to the next one, semi-parametric model. Semi-parametric means half of the part. That means only partial parametric models. So coming to the first one, Cox proportional hazard model. So it is used to relationship between survival time and explanatory variables. Survival time means, for example, if you are analyzing the particular data, for example, at the 20 years of age, 30 years of age. So 20 years of age we will get less chances of heart disease, and 30 years age we will get some more chances of heart disease. We are taking the example. So based on these two analyses we have to choose only less chances of heart disease. So that is the survival time. So for this analysis, how much time it will be take? The explanatory variables means after analyzing these two variables and which one will be very higher compared to the previous one. So that will be explained in this proportional hazard model. So that is about the Cox proportional hazards model. So it is a new treatment. That means based on the previous historical data, we need to analyze and we need to execute that one with a simple way and with small amount of time. It will be executed continuously. So that is about Cox proportional hazard model. So now exponential model. So exponential model means, if for example if we are changing the data, for example if we are having 100 rows of data set is to be there. So if I have to solve the starting row to 100 rows, it will take more time to execute this one. That is exponential model. So if we have to increase the count, the particular time will be increased based on our constraint. So that is about exponential model. Next one, log normal model. So log normal model means based on the curve. So logs means based on our using. Just like for example, if the particular person uses 9 o'clock, 9, 10 in the same day, and what they are using and what he will use. These all the contents will be placed and shows in the form of distribution, normal distributions like this. So that is about log normal model. Next one, non-linear models. So actually logistic regression belongs to linear model as well as non-linear model. Why we are calling the logistic regression belongs to linear model and non-linear model means, so in the logistic regression they show the curves like the straight lines or different formats. Now see the difference between, actually in the previous I given linear model. In the linear model it is a relationship between independent variable and dependent variable, and the graph will be shown in the form of straight line. So in case of non-linear models means it is used to show the graph in the form of curved shape. The curve like this, the curve will be increased like this. So in the different format of the models we have to be shown in the form of logistic regression. So now logistic regression, that means the output will be in the form of binary or the categorical. So binary or the categorical means, for example, category we are taken, so particular gender. So the gender we are taken, the male or female or transgender. So the output may be 0 or 1. So like that we are taken. So that is about the logistic regression. So it contains the output in the form of 0 or 1. So between the independent variables and the probability of event occur using logistic function. Second one, neural networks. So neural networks means it is one of the type of ANN, artificial neural networks. It is used to show the curve in the form of curved shapes like this. And these all are nodes. Every point is a node. Whenever we are giving the node, so these all are individual node, node 1 like this. For every path they are having some of the points. These all the points are called as nodes. The connection between all the nodes that is to be shown in the form of graph, that is called as neural network. And that node means the human brain parts, axons. These all are the different parts of the neural network. So now, see this example. If the school wants to predict the student performance based on their demographic information and academic history and learning behavior. So based on the student performance, writing of the exams and their exam performance and the school discipline, everything they are considering, and based on that they are assuming this person is having high performance and high discipline person, like that they need to assign the variables. The next one, spline. So actually spline means it is a smoothed curve. So it is used to represent the line charts. So that line charts may be curved shapes or straight line, or different types of formats are to be there with the various fields, and that is to be related with the computer aided design, engineering and data analysis parts. So computer aided design means the graph will be represented in the form of different designs, just like different shapes, bottle shapes, or different types of computers, or different types of mobiles. Different types of shapes will be represented by using the splines. So in the spline, it is a piecewise function. So piecewise function means just like pieces, just like they are cutting into pieces like this. These all are called as individual pieces. This is called spline. So for each and individual parts, we are calling the one piece, spline piece 1. This is piece 2 and this is piece 3. So like this, we are representing the spline like this. So here I have taken the medical research in between the continuous variable and the response variable. Continuous variables are age and dose, and next blood pressure and tumor size. So if the age and particular dose will be increased for the particular person, so they get the blood pressure, and the tumor sizes also will be increased based on our patients. So that is called as spline. Spline is used to represent the data in the form of pieces. Pieces means parts. Just like 0, 1, 2, 3. So 0 to 1, one part, that means one piece. 1 to 2, 0 to 1, one piece. 1 to 2, one piece. 2 to 3, another piece. Like this, the pieces will be distributed in the form of splines. So that is about splines. Now, there are 5 types of splines are there. First spline, piecewise polynomial splines. So piecewise polynomial splines means, so the data they are to be taken. So see this one. So at the value of x and y value is 0 and the value of 4 value is 0. So that means, so there is no output for that variables. So see here, at the value of x is equal to 1, 2, 3, they are getting some of the output predicted variables. So the output will be 0 means there is no occurring, that means there is no event will be performed at the time of the condition. So here also there is no event performed for the condition. So that's why we are taken first curve passes through the data points. So data points are what? 0, 1, 2, 3, 4. These all are the data points. These all are our data points. So next y is our output values. So curve passes through the data points means they are taking 0 to 4 values. And next the knots. Knots means up to what from what interval to what interval they are getting the values as numbers, not 0. So x is equal to 1, 2, 3 case they are getting some output as 2, 3, 2. So that's why we are taking the knots like this based on the condition. So continuous first and second derivatives of the knot. So first and second derivatives means you already know the derivatives of the particular equations. I will show you. So these are the equations for the states. So a1 x cube, b1 x power 2, c1 x plus c particular d1. So first the states like this. 4 expressions are there, 4 values are there. Why? Because they are starting from 0 up to 4. So that's why we are taken up to 4 expressions. A1, B1, C1, D1. 4 x values are there. So that's why we are taken 4. So why? Because the first one is 0. So that's why we are not starting from 0. So next, after taking these all the values, we are taking some derivatives. So final C, for example, if our x1 value is x value 0 in this case. So x power 0, these all x value 0. So these all are 0. So finally that value will be 0. Next, second condition, a1, b1, c1. So next value is 2. Like this, the values will be increased based on our conditions. So now in this piecewise polynomial equation means the values will be taken like this: 0, 1, 2, 3, 4, 5. 1, 2, 3, 4. 4. See, up to 1. This is one piece 1. The condition is 0 to 1. This is piece 1. Next, piece 2. Next, piece 3. Like this. See, the line will be like this. So this is about the particular piecewise splines means this one. Next one, natural splines. So natural splines means the data, whatever the data we have to begin. For example, I have taken the cube points 0, 0, 1, 2, 2, 3, 3, 2, 0, 2, x is equal to 1 and 2. So for the condition, if 0 to 1 means the x cube plus 2x power 2 is 0. 0 to 1 interval, this condition is this one. Next 1 to 2 interval, the condition is this one. And in case this condition 2 to 3 interval, the condition is, equation is this one. Now see, the spline satisfies the natural boundary conditions f double dash of 0 equal to f double dash of 3 equal to 0. If the condition will be satisfied means it is a natural spline. So now see this one. So f dash of 0. F dash of 0 value is 0 only. Why? Because x value 0 means all the values will be 0. So next, second condition. So second 1 to 2 means minus 2. Next, minus 3. Why? Because these all the values are 0. This value will be there and this value will be there in the second and third conditions. So f of f dash of 0 value is 0, minus 2 and minus 3. Next, f double dash of 0, and that means again we need to derivate. So 0, 0, 0. Why? Because these all are only constants. Next, f double dash of 3, 0, 0, 0. Why? Because if the value we are derivating as 0 means those all the values are 0. So at the condition of f double dash of 0, f double dash of 3 or f double dash of 4 or f triple dash of 4, the value will be only 0. So that is about the condition of natural splines. The equation for this one is starting from this one like this. This is natural spline. The equation will not be starting from origin. After one point, the value will be started and the line will be started here and the points will be displayed like this. So that is about natural spline. Next, B-splines. So B-splines means the data is to be shown in the form of basis functions as well as knots. So B-spline means it is these all the equations are to be x minus 0 whole power 2 means 1 and 0. 1 minus or 2 minus whole power 2, these all the values are 0. So the curve will be represented like this. And they don't have x-axis and y-axis. Directly they are drawn one line and for this the curve will be drawn like this. So this is called it as curved curve. Curve curve. B-splines means curve curve. B-shaped curve. So these will be executed recursively. So it will be executed in the same line and they will be calls itself like this continuously. So that is about the B-spline. Next one, the last one. So the equation for B-spline is C naught into B naught x, B1x and B2x. So B naught, B1, B2, these all are the B-splines. So that means the B points that is to be there based on the equation. So B naught means x minus 0 whole power 2, x minus 1 whole power 2 and next x2 minus 2 whole power 2. So that is the equation we have to be taken. Next, smoothing spline. So smoothing spline means it is used to minimize the sum of square residuals between the observed data and the spline. So observed data means previous historical data we have to be observed and the smoothing spline like this, that will be represented like this. This is called as smoothing spline. So smoothly in the curved shape, that is starting from here and next continuously that will be increased and like this the value will be 2 like this 0, 4, 6 like this. That is called as smoothing spline. So finally these are the different linear models and non-linear models. Finally I will give linear models means it is a relationship between independent variable and dependent variable and the curves will be in the form of straight line. So linear means in the form of curves or line, and in case of non-linear models the outputs in the form of curved shapes or like this or like this, any type the curve will be shaped. That is called as, these all are called as non-linear models and this is called as linear models. So this is about the linear models and non-linear models are to be used in the regression. Thank you.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.